Hello everybody. I'm just going to be going over all the worksheets that you have done while I have been gone. Also, enjoy the mustache, will not be here for long. I had it for freshman retreat. So, I'm going to go over everything from classification of matter onward. I think this should be recording my screen well. So, I'm going to run through the worksheet myself here. Once it decides to load for me. Any minute now. So, actually I've gone through this before, and so it actually already has it done for me, but I will go through each of these one by one. So first we have elements. Elements are anything that can be found on the periodic table of elements, and as only one thing. However, it might not always be the name that matches. I'll go through that. Gold, silver, oxygen, hydrogen, sulfur are all elements that you can find directly on the table. But sometimes we have individual chemicals, elements that have multiple forms. One of these is called carbon. The multiple forms are actually something called allotropes, although that's not something we really cover in this class, but that is allotropes, allotropes. Graphite is one of the allotropes of carbon, the other being diamond. So graphite is a pure element. Other things that could be a pure element would be something like a pure iron bar, right? Or aluminum foil. Things like that, where yes, it might not be the exact thing you see on the table, but you know that it is made exclusively of one element. So graphite is all carbon. Then we get into compounds. Compounds are two or more elements, different elements, which are chemically combined together. Sucrose is a sugar made up of carbons, hydrogens, and oxygens. Water, H2O. Carbon dioxide, CO2. Right. Mustard gas, sodium chloride, calcite. For those who don't know, because there is often a confusion between mustard gas and chlorine gas. Mustard gas does have chlorine, but it is not chlorine gas. So then we get into mixtures. Actually, I think this is wrong. Let me... Here we go. Blood should be as a heterogeneous mixture. There we go. So we have two kinds of mixtures. Mixtures are chemicals that are combined, but they're not mixed, or they're not reacted together. They're simply mixed together. So, some homogeneous mixtures. Yellow mustard. Right, generally, this is a homogeneous mixture. Now, technically, it's actually a little bit of a heterogeneous mixture. One of the definitions of a heterogeneous mixture is, right, you can see the different separate parts. Yellow mustard, as a homogeneous mixture as you cannot. So yellow mustard, right, is generally a homogeneous mixture, although sometimes, you know, when you first open it up, you spray it out, and the water in the mustard has kind of run down to the bottom, and you get that, like, mustardy water that kind of, you know, that gross stuff. That's why you, like, pat the bottom first, because you don't want that. But when you look at really, like, the mustard part, like what we actually view as the mustard, right? Not the water that comes from probably the condensation in a refrigerator, things like that. That's homogeneous, right? You can't tell one part of the mustard from another. Same with salt water. We know that it's water with salt dissolved in it, but we can't tell the difference between the salt and the water. Clean air, right? Generally, you can't see anything in the air. That means it is all mixed together well. It is a homogeneous mixture. Rubbing alcohol. Rubbing alcohol is usually 70% isopropyl alcohol. Right? Even without knowing what the other 30% is, usually water. Right? If it's 70% one thing, it means the rest of it's something else. It's a mixture. But look at rubbing alcohol. You can't tell the difference. Coffee as a drink. It can leave a stain over time, but generally coffee is a very homogeneous mixture. And brass. Now this one's a tricky one. Right, and actually this one I kind of knew that people might not get. I wanted to include this one as a jumping off point in my video to discuss alloys. An alloy in a metal is technically a mixture. An alloy is when two different elements, one of them being a metal, are combined together to make a new metal. An example of this is steel. Steel is actually not its own chemical compound. Steel is a mixture of iron and carbon. It is iron molecules that have small carbon, or iron atoms that have small carbon atoms in between them. This ends up making the steel stronger, and generally, alloys are stronger than pure elements. Dirty air. A heterogeneous mixture is one where you can tell the different parts. If you can see that the air is dirty, that means you can see different parts in it. Dijon mustard. Well, Dijon mustard usually has small little specks in it. Right. Oftentimes, you know, stuff that's been ground up. Dirty water, right? If water is dirty, again, you can see the stuff in the water. If you can see mud and sand and dirt floating around, then it's not homogeneous. Trail mix. This is kind of the classic example of a heterogeneous mixture, right? A bowl with M&Ms and peanuts and raisins, right? Each of those are separate components that are clearly, right, not combined. Apologies. Ground black pepper. Alright, you're going to see ground black pepper. If we take a look, right, it can be easy just to think of pepper as black because we view it as black to distinguish it from salt being white. But if you look at, right, black pepper is generally multiple colors. It's always multiple colors. That's because there's multiple things that make up a peppercorn. So when you grind it up, you're getting all the different parts. And blood looks homogeneous at a first glance, but it's actually not. It's heterogeneous. Have you guys ever seen like blood centrifuged? Right, we have various things in our blood. We have plasma, we have blood cells, and other smaller components called a buffy coat. that has platelets. Right. Our blood has multiple components. That's why if you have a blood test done, you will actually, right, kind of see this yellow coating on the top when you get a blood draw. It's easy to look at it and think that that is a color left over from the blood draining down, but that is actually its own distinct liquid. So next time you have to have a blood test done for something, pay attention to that, right? Yeah, I know that doesn't always happen, but if you do. Alright, now our graphical organizer. Fill it in with the appropriate words. Well, this first one, right, is just matter. All the stuff in the universe is matter. Going from matter, we have two different kinds. We have pure substances, and we have mixtures. Pure substances are chemicals that are substances that are all chemically identical, whereas a mixture is different chemicals combined. A pure substance is not just an element, right? An element is a type of pure substance, right? But so is a compound. If you have a bowl of just sodium chloride, you might be thinking, well, it has sodium and chloride. Yes, but the sodiums and the chlorides are chemically combined together. They're not just going to separate and go off on their own, right? They are chemically combined. And therefore, they are all the same substance and they have the same properties. Heterogeneous mixtures and homogeneous mixtures are the two kinds of mixtures. As we just discussed, right? Particles are not evenly spread out. We see some in different places. You can usually visibly tell the difference. With homogeneous mixtures, the particles are completely evenly spread and you can't tell a difference between one part and another. Tea is an excellent example of a homogeneous mixture. Alright. What time are we at? 12 minutes, okay. So that was the first one. If anybody has any additional questions, please let me know. Actually, one last thing I want to talk about with classification of matter, which I believe I mentioned in my video. In case I didn't, as far as classification of matter goes, right, or as far as elements versus mixtures go, pure compounds versus mixtures, sorry. Pure compounds all have their own unique and distinct chemical properties, which I'll talk more about when we get to the chemical properties worksheet. Every single compound will have the same chemical properties if it is a pure substance. They are all identical. Every two pieces of salt are going to taste salty in the same way. They'll react in the same way. They'll have the same molecular mass, which is just atomic mass for a whole compound, right? They will have the same density. They will, have all these different properties. Unless they have some sort of impurity, they'll have the same color as well. Whereas mixtures are a combination of the different densities, and we can take of the different properties, and we can take advantage of that. If I chemically combine two elements to make a new compound, it's not a mixture of their properties, right? Sodium blows up. Chlorine gas is poisonous and kills you. Sodium chloride goes on our food. So when two chemicals react and they make a new compound, the compound is not a mixture of properties, but a mixture is. That's why we can take very sweet lemonade and we can water it down by mixing it with more water, and we can combine the properties with water to dilute it and water down the taste. So anyways, You already had the quiz review. I figure I'll run through it real quick, but you guys did great on this. Right. Right here we have our alkali metals, our alkaline earth metals, with this whole area being just metals in general. You don't even need to know these, but I figured to throw it on here. Lanthanides, and actinides, and lanthanides, right down here. Non-metals are up here in this region, 9, while 8 are the halogens, and 7 are the noble gases. These are what we call our transition metals. They are going to be the metals we generally ignore this year. And 10 are our metalloids. So as far as metals, non-metals, metalloids, really you already have them written here, right? You have them labeled by color. Copper, metal, oxygen, non-metal, hydrogen, non-metal, potassium, metal, phosphorus, non-metal, helium, non-metal, aluminum, metal, calcium, metal, magnesium, metal, chlorine, non-metal. No metalloids in these ones. But like I said, the metalloids are here. Again, you will see some periodic tables have some differences in labels. Some of them might refer to polonium as a metal. Some of them might not. Some of them might include astatine as a metalloid. These elements, being radioactive, aren't as well studied and fully understood. So properties of metals and nonmetals. What metals are shiny, they're lustrous, usually. They don't always have to be. Some of them can be dull. They are, right, like iron. Metals conduct heat, they conduct electricity, they lose electrons easily. Nonmetals, bad conductors of heat, bad conductors of electricity. They have varied properties. So that actually is a property of nonmetals, is that their properties vary. And they gain, right, they gain electrons when they react. Of course, that would be a chemical property, not a physical property. Let's keep going, though. For a quick verse for your Sal Day assignment. When classifying matter as either a pure substance or a mixture, then as an element or compound, and a solution, aka a homogeneous mixture, or a mechanical mixture, aka a heterogeneous mixture. One way you can tell if something is a heterogeneous mixture, in addition, is if you can mechanically separate it, which is why we call it a mechanical mixture. For example, right, if I can physically go in and separate the mud from the water with a strainer, right, or a purifier pump, if I can physically separate them, then that's a mechanical mixture. So, laundry detergent, which contains white and blue crystals, right? If they contain separate crystals, and you can see those individual crystals, right, then it is a mechanical mixture. Let me show you real quick. So it's a little hard to see. I actually don't have any solid laundry detergent right now. Mine is in the liquid form. So I grabbed a dish detergent, right? And if you look carefully, you can see the little speckles in there. At first, they might look like they're holes, right? Let me check that this can be seen. Ooh, hopefully you can see it. Yeah, the speckles there, right? Those are different chemicals. Even without the green and the blue liquid at the bottom, right? That is a mechanical mixture. If I wanted, I could break this open and I could mechanically pull out all of those little other crystals. It would take a while, it would be annoying, and it would probably not be worth my time. But I could do it. Sugar and pure water. Sugar dissolves in water. Try making some sugar water, you won't be able to see it. Unless you try dissolving too much, there is always a limit to how much stuff can dissolve. But assuming you haven't reached that limit, this would be a mixture because it is two different chemicals, but it would be a homogeneous mixture. Iron filings, that's a pure substance, and that is also an element. It is one chemical. So iron filings, as a fun fact, are actually how we have iron-enriched cereal. Iron-enriched cereal isn't like other, nutrients and stuff where it's part of a compound, right? It's just straight up iron shavings, iron filings. Limestone. Limestone is another pure substance. It is a compound because it has both calcium, carbon, and oxygen in something we call calcium carbonate. We'll get into calcium carbonate more probably next week or maybe when I come back. It is a rather difficult chapter. Orange juice, which is made of water and pulp. So, this is a mixture. If you have pulp-free orange juice, that can be a homogeneous mixture. But here we have a specification of pulp, so that would be a mechanical mixture because you could strain out the pulp. The Pacific Ocean. Well, it might be mostly water and salt, and we might look at the ocean first and want to classify it as a homogeneous mixture. But think of all the stuff in the ocean, the tiny microorganisms that are floating around, all that fish poop, right? The fish, algae, and other different aquatic fauna and flora. The Pacific Ocean is one giant mechanical mixture. You can yourself start separating parts of it if you just go fishing, right? Or grab a strainer and just pick up some water. Air. Just like I mentioned in the other one, air is a mixture, but it is a homogeneous one. Aluminum and magnesium are both elements on the periodic table, meaning they are pure substances and elements. Acetylene. That is a pure substance, but it is a compound. Tap water in a glass. I believe I mentioned this to you guys before, right? But tap water is a homogeneous mixture. It is possible for it to be a heterogeneous mixture if you have a pollutant in your water. Generally, right, one way you can tell how many things are dissolved in your water is the taste. If water tastes very metallic, you have a lot of calcium and magnesium in your water. You have to be careful though, right? You cannot drink completely pure water. You would eventually get sick. That being said, pure water is just a pure substance and a compound at that. Soil. This is a classic heterogeneous mixture. You can look at soil and tell all the different parts. Chromium. Chromium is an element on the table. Baking soda is a compound. Salt water with pure water, right? This is different from the ocean. This is a homogeneous mixture of two pure chemicals. Benzene. Benzene is a chemical, right? It is a pure substance, and it is a compound. Muddy water. This is a heterogeneous mixture. Brass. I even gave a hint here that copper was mixed with zinc. It is not chemically combined. It's instead what we call a solid-state mixture, which is a pretty rare form that we usually don't think about. But they're just mixed. They're not chemically combined. And pizza, of course, is a heterogeneous mixture. right? Cheese and bread and sauce, all separate parts. All right, we are at 25 minutes. Let's cover the last worksheet. The physical chemical changes and properties worksheet I gave you. So let's talk properties first. Properties come in two forms, physical and chemical properties. Physical properties, as we see here, can be observed with senses. Like, that's red, that's big, that's small. Right? Some of these properties, in chemistry, we generally will refer to the intrinsic properties. Intrinsic properties are properties that are always true for a certain chemical. For example, blue color. Copper sulfate is a blue chemical and will always be blue. Density is intrinsic, as we covered in our density lab. Every instance of a chemical has the same density. Right? We have other physical properties, things like length, or height, or mass, or other things that might not always be true. These are called extrinsic properties. They are only true for certain parts of that group. Right? Generally, every instance of a chemical will probably have pretty unique extrinsic properties, because it's hard to have two things exactly the same. But intrinsic properties will always be the same. We are going to stick to mostly intrinsic properties here, because those are the ones we use for identification in chemistry. We, of course, use extrinsic properties. We take mass all the time, for example. Right? But intrinsic properties are how we identify chemicals. So, color and density. These are physical properties. Melting point and boiling point are both physical properties. Hardness, how hard something is a physical property. Luster, how shiny it is. And odor, how it smells, are both physical properties. But let's talk chemical properties. Chemical properties indicate some sort of chemical reaction is happening. So some of them are more obvious. All right, for example, reacts with acid, reacts with water, and reacts with air. Those are all pretty clear chemical properties. But let's look at some others. Flammability. Fire is a chemical reaction. Right? Supports combustion. Right? That is also, again, a chemical reaction. That's just more flammability. And maybe the hardest one to get here would be sour taste. Right? This one, to be honest, I actually think you can make an argument for either. The taste of a chemical is a physical property. I realize I skipped solubility. I'll do that next. A taste of a chemical is a physical property, right? And yet, you generally only observe it in the instance of a chemical change with, as it interacts with your mouth. Same with odor with your nose. Generally, though, it is a physical property. You don't need to change it into a new substance to observe it, because you could instead just have kind of a short direction. Like if I taste sugar, the sugar isn't changing into a new substance. What it's doing is it's coming into my mouth and it is interacting with my taste buds. It might react a bit with them, but it's not changed. It's still sugar. Right? My body is going to break that down later and use it for energy, so it can't be changed when I'm tasting it. And so if you overthink it, you might come out with taste being a chemical property. But it is a physical property. And so is solubility. Solubility is how well something dissolves. We might think of this as a chemical property, but again, this doesn't change the chemical. In the same way that if you dissolve salt in water, it's a mixture, not a new chemical, right? It's a physical property, not a chemical property, because it is not combined to make something new. All right, now let's talk about changes. Changes, right, are, again, just something physically changing or chemically. Okay, so change, yeah, is an actual change to the substance itself. If I tear this paper in half, that is a physical change. The paper is still paper. But a chemical change, right, changes something into a new chemical with new properties. So let's talk about these. Sodium chloride, table salt, dissolving in water. It's still salt, it's just in the water. Therefore, that is a physical change. I'm going to go through all the physical changes first, then I'll run through and do the chemical ones, and I'll explain them as we go. An apple is cut. If you cut something, just like with the paper I described, it is still the same chemical, still the same substance. Heat, changing water to steam. This is a tough one. People often like to assume that a state of, a change of the chemical state of matter would be chemical. But it's actually physical, because it's not breaking apart the water. Water goes from being in a condensed liquid to separating out as a gas. So really, when you put in all the heat, all you're actually doing is separating those molecules in the same way that you could separate two halves of paper by tearing it. Alcohol evaporating. This is the same thing. It's just, right, different from boiling. Well, it's pretty much the same as boiling. It's a change from liquid to gas. Ice melting, same deal. A state matter change. Right, sugar dissolving in water. Dissolving is a physical change. A tire is inflated. All you're doing here is putting air inside the tire. That is a physical change. Paper towel absorbing water. A physical change. It's just sucking up the water and holding it inside. You can think of it like the water is dissolving in the paper towel if you want. So, then we have our chemical changes. Silver tarnishing and iron rusting. When things, this is something we call oxidation. When stuff reacts with air over time and changes, right, its properties are different. Tarnished silver is no longer shiny. Rusty iron is no longer strong. We also have baking soda reacts with vinegar. Reacts is right in the word right there, so that's it. Milk sours. Here we can observe a change in chemical properties. So milk reacts with bacteria in the milk over time to sour. Wood rots. The wood is decomposed by bacteria, right, which causes its properties to change. It becomes soft, right, and easily breakable. These ones are a bit harder to see. Pancakes cook, grass grows, and food digested. Well, when you cook something, as we'll actually cover later this year, it is a chemical reaction. You are going to different substances. Well, the taste might be similar, right? Pancake batter and pancakes are not the same. Grass grows. Well, when grass grows, right, the seed germinates and then it takes in nutrients, and the nutrients with the plant combine to start producing the blade of grass. It is physically created through chemical reactions. And finally, food is digested. When we digest food, right, our stomach acids are reacting with them. That is a chemical reaction. All right, I'll go through these real quick, and then we will call it a night, because it is almost 11 p.m. An ice cube melts. Physical. Two chemicals are mixed together, a gas is produced. If you have a new chemical being made, right, that's a chemical change. Bike changes color as it rusts. Rusting is a chemical change. It's turning from iron into rust, or steel into rust, as steel is just iron with carbon. Chemical. A solid is crushed into a powder. Crushed being a physical thing, it's still the same chemical. Physical. So that is a physical one. Two substances are mixed and a light is produced. If a light is being produced, that is a good sign that it is a chemical change. Light is one of the signs of a chemical reaction that we will cover in the next few chapters. A piece of ice melts and reacts with sodium. Well, this is a physical and a chemical change. First, it melts, then as a liquid, it reacts with sodium in a chemical change. Mixing salt and pepper is just a physical change. Chocolate syrup dissolving in milk, dissolving is physical. Marshmallow toasted over a campfire. As it toasts, it changes its physical properties, right? The color turns brown as it goldens, and it gets a slightly tougher, hardened surface. But if you cut a marshmallow in half, well, that's just physical. And finally, down here we have our last page. Let me check the time. Okay. All right. A student removes a loaf of bread hot from the oven. They cut a slice of the bread and spread butter on it. That is a physical change, cutting the bread. And spreading butter on something is just creating a mixture, a physical heterogeneous mixture. Your friend decides to toast a piece of bread, but leaves in the toaster too long. This is a chemical change. The heat causes a chemical change in the toast, which causes it to harden. It changes how it tastes. It changes its properties. You forgot to dry the bread knife. You washed it, and now red brown spots appeared. That would be rusting. That would be chemical. You blow dry your wet hair. This is just drying out. It's causing evaporation of the water in your hair. It's physical. Baking powder reacts. Chemical. You take out your best silver spoons. They're dull. They have black spots. Tarnishing. Chemical. A straight piece of wire is coiled to form a spring. That is a physical change. Food color is dropped into water to give it a color. That would be dissolving. It's still the same thing. It's still water. And dye as a mixture. That would be a physical change. Just think about a Gatorade. If you look in the bottle, you can actually see the food dye as an ingredient. Right? And whenever you see a long list of ingredients like that, it is a mixture. Because if they reacted to form a new chemical, they would just describe the new chemical. So, chewing food to break it down into smaller particles is a chemical change, but then digesting it with enzymes is other way around. Chewing is physical, but digesting is chemical. In a fireworks show, the fireworks explode, giving off heat and light. They give off heat and light like our flame tests because they are reacting. They are chemical changes. Next, we have changing the size and shapes of pieces of wood. That is false. That is physical change. Makeup of matter is changed. Nope, that is false. Makeup of matter is not changed. Evaporation occurs when the liquid water changes into a gas. Yes. Evaporation is physical change. Yes. Burning wood is a physical change. No. Fire, right, is a chemical change. Combining hydrogen and oxygen to make water, that is a chemical change. You're changing the chemicals. It's no longer hydrogen and oxygen. Breaking up concrete, completely physical. Sand being washed out to sea from the beach, that's physical. When ice cream melts, a chemical change occurs. No, that is physical. Right, states of matter. Acid rain made damaging a marble statue is a physical change. No, it is a chemical change due to them reacting with the acid. Hopefully this is helpful. Hope you all have a good night. Hope you enjoyed the mustache. Have a good day tomorrow.